Okay, so this is the check it out number 4 on page 821. It's underneath example 4. In one day, 5 different customers bought earrings from the same jewelry store. The store offers 62 different styles. Find the probability that at least 2 customers bought the same style. So what do we know? We know each person has 62 different styles to choose from, and we know that 5 people are choosing. The denominator would be easy in this case. The total is going to be 62 choices times 62 choices times 62 choices times 62 choices times 62 choices for 5 people. 1, 2, 3, 4, 5. So the bottom is just something over 62 to the 5th power. The hard part is how do we figure out at least 2 customers bought the same style? So we have to think about what that means of at least 2 customers. That means that of the 62 different styles, 5 people could choose the same thing. So there's 2, there's 3 people could choose the same thing, there's 4 people could choose the same thing, and then there's 5 people could choose the same thing. And that's actually more confusing than just finding out that. But that is something to keep in mind. The only thing that at least 2 customers isn't is they all have something different. Okay? Now, we'll talk about that, but total is easy. The hard part is figuring out the numerator. The thing you have to know about probability is when you all choose different options, it's easy. But when you have the ability to choose the same, it becomes more complex. This will be difficult to show you because the way they want you to solve only makes sense if you know how to do both routes. I will explain that the hard way is by finding the probability of getting 2 that are the same, 3 that are different, then 2 that are the same again, with 2 others that are the same, but that's a different scenario. Yes, they are different outcomes. 3 that are the same, 2 that are different, 3 that are the same with 2 others that are the same, 4 that are the same with 1 different, and all 5 are the same. All these scenarios would have to be put in as combinations because order doesn't matter in these cases. Then you would multiply them all together and take them over the total. That's a lot of things to find just to solve this problem. This math book would not have you do this if this was the only way to solve this problem. There's a backdoor route. And to think about it, since I can't really show you the complex way without just making your head explode, let's just look at a simpler problem. Okay? As an example, think about finding 90% of something that is $19.70 without a calculator. Most people would find 10% because it's easy to do in your head. You just move the decimal place one place to the left and it becomes 197. But what about 90%? We would have to take 1.97 times 9 to find 90%. That's one way to do it. That would be the solution, but 1.97 times 9 isn't easy to do in your head. The smart thing to do is to find 10% like we did, 197, and then subtract it from 100%, which is the original cost of 1970. So now to find 90%, we just take 1970 minus 197. It's not a perfectly easy problem, but it's something you could do in your head versus 1.97 times 9, which would be very hard to do in your head. You'd have to get out a piece of paper if you couldn't use a calculator. But this you could do in your head. So that's kind of my point here is 1.97 times 9 to find 90%, or just subtract it from 100%, you got it. That's a lot easier. This is very similar in the way you do it. Don't find all that at least 2 is. Just find what it isn't and subtract it from 100%. The only outcome that is at least 2, and what it isn't, is that all 5 customers choose a different book. So all 5 customers pick a book that are different. That's easy to do because you did that in the last lesson, permutations. You just do a permutation. 62 choices, choose 5, which would be 62 times 61 times 60 times 59 times 58, but you can also do the permutation in your calculator. I don't know what you prefer, but it would be 62p5 over the total again, which was 5 62s multiplied together. That is 84 roughly % chance. Okay? That is what at least 2 isn't. Now take off 100%. Now take it off. Take it off 100%. So 1 subtract 84.76% and you get 15.24%, or 0.1524 if you write it as a decimal like I did. Well, that's a lot easier than finding all those other outcomes and adding up to this. Or you can take everything that it isn't in one false swoop and take it off 100% and get it a lot faster, a lot easier.